Question 16.05, question 11. Now this is getting a little bit more involved. A few more things to move around before we can find x. We're making x the subject here, of course. So I'm actually going to write it the other way around. I want all the x's on the right-hand, sorry, on the left-hand side, and all everything else on the other side. So I'm just going to write here 3x minus 1 all squared plus 2 is equal to y. So I'm going to start off the other way around. I'm going to strip away all the elements until I'm just left with the x. So my first job will be to subtract 2 from both sides. So now I'm going to, each time I'll rewrite it out so you can see how it gradually gets closer and closer. This is 3x minus 1 all squared is equal to y minus 2. I'm going to divide both sides by 4 now. Here we go. So I've got now 3x minus 1 all squared is equal to y minus 2 on 4. I'm now going to find the square root. Sorry, you can't see that. So I divided both sides by 4, and in doing so, I got rid of the 4 for the coefficient, and I ended up with a 4 underneath the y minus 2. So now what I'm going to do is I'm going to find the square root of both sides. So find the square root of this side, and the square root and the square will undo each other. I'm also going to find the square root of this thing on the other side, and of course this will be plus or minus the square root of y minus 2 over 4. Now we can actually simplify this a little bit, because although we don't know the square root of y minus 2, we do know the square root of 4, and the square root of 4 is 2. So when I rewrite this next time, I can actually just write y minus 2 with the square root all over the square root of 4, which of course is 2. I almost wrote 4 then. All right, on this side, of course, we're left with 3x minus 1, and this is plus or minus. So now what I'm going to do is I'm going to add 1 to both sides. So add 1 to this side, add 1 to this side, and I'll just put a plus 1 there. So of course 1 and minus 1 leaves me with a 3x, and that equal to, I'll put that 1 in front of the plus or minus there. So I've got a 1, I've got a plus or minus root y minus 2, and that bit there's over 2. Sorry, I keep doing it so you can't see it. I do apologize. Now I'm going to divide both sides by 3. So I can divide this by 3, which of course leaves me with x, which is exactly what I want. I can divide this by 3, because I have to divide the whole thing by 3. But this is in 2 parts. It's 1 plus or minus all of this here. So I can divide the 1 by 3. I can also divide this by 3. And when I divide a number by 3 with a denominator, all I have to do is multiply the denominator by 3, and I've automatically divided all this by 3. Now, as I look at this, I notice that 2 times 3 is 6. Now, I could also make this into 6 if I multiply this thing at the top by 2 and this thing here by 2. So really, this is now 2 sixths. So I could either write 2 sixths plus or minus the square root of y minus 2 all over 6. Or I could notice, well, I've actually got the same denominator here. This looks like it's up to the top here, but it's really 2 sixths plus or minus the whole of this thing here. So I could actually write instead, I could write 2 plus or minus the square root of y minus 2, but it's all over 6. So I can now get a common denominator, long vinculum, and I could just write 6 on the bottom, and there is my solution.